Yeah, this mic is a little ways away. So first of all, I wanted to thank everybody from last month. I got some really nice comments about the binocular talk, and I hope everybody got a little bit out of it anyway. And thank you very much for your comments on that. If there's some topics that you'd like me to cover too in these beginner series, or maybe follow up with some things that maybe I missed in the first talk, please let me know and I can do a follow-up as well to some of these, okay? So today we're going to talk about star hopping, and I'm going to basically cover the basics, but I'm going to start with a bit of a primer on how we see the sky, and then I'll lead into it. It'll make sense in a few minutes here. Let me just start here. Just before I go to that, I was talking about binocular books last month during the talk, and this book came out about a week after I did my talk, and I ended up bringing a copy of it with me. I picked it up, and it's not too bad. It's about $18 Canadian on Amazon. The charts could be a little nicer. It's all kind of black and white, but it is chock full of things for those of you who maybe are a little rusty or are looking at some easy sky candy to look through binoculars. So I just wanted to mention that really quickly. One of the things with star hopping and stellar reckoning in general, the ancient Polynesians stand out, I think, in some ways, because they were masters of being able to navigate a vast ocean and find these tiny little islands, right? And I think it's a real testament to their ingenuity, because they were actually knew the stars seasonally well enough to be able to go to islands and trade and explore the ocean. And what they did basically is they gauged star angles and distances using basically just their hands. There was no GPS, no compasses, and it was just your eyes and your arms and the wind and the sun and moon, I guess, in the daytime. Most of their sailing was done in the evening at dusk, so that they can find the bright stars to guide them. So we're going to follow along in that kind of tradition a little bit. And basically star hopping is our way of dead reckoning the sky. So instead of going island hopping, we're going to be looking at regions of the sky and using familiar patterns called asterisms to be able to do this. Now, I'm going to need you guys to then twist your mind inside out a little bit for a few minutes. You'll see why in a minute. But for those of you that remember the original Total Recall, I thought that was a good slide for that. Now, it's also very interesting, when we look at the history of astronomy, just especially modern history, we're inside the box and figuring out what the box looks like from without somewhat. And that's kind of a real testament to how our observational and photographic techniques have actually allowed us to do that. And just to reiterate here, we're just a little past halfway from the center of the Milky Way. And so our location in our galaxy has a lot to do with what we see seasonally. And I'll talk about that in a few minutes as well. Whoops, wrong way. All right, keep going. Okay, so here's the one that you kind of have to, don't get scared on this one. But basically what I wanted to iterate here is, if you consider this sort of our galactic plane, well, it isn't sort of, it is the galactic plane. Our sun actually is at a slight angle, and it orbits above and below the plane of the galaxy, okay? A little bit. And there's no requisite that our coordinate system should be in line with our galaxy. And that's one of the things that we just have to keep our minds open on when we're looking at the sky visually, or even doing photographic surveys or aiming our telescopes. So as you can see here, we're about 60 degrees from the galactic plane here. We're tilted. And then we also have our Earth that's tilted relative to that. And it's not necessarily aiming directly at the galactic pole either. So that has some real implications when we start looking seasonally at different regions of the sky. And I've got some other diagrams coming up that'll iterate that a little bit, and that'll help us understand some things. So if we look at the galaxy kind of a little bit more obliquely, you can see here's our position roughly in the galaxy, okay? Instead of looking edge on, now we're looking down at an angle here obliquely. And I just picked a couple of approximate locations here for some common items that we would look at. The local Orion arm, you can see here, we're kind of looking away from the center of the galaxy. And of course, M15 would actually be off the chart a little bit here in a bit above. But this is just to kind of give you some perspective as when we're looking at the sky at different times of the year. You can see this kind of thing very easily. Now, another thing that I know a lot of you are very used to this, but it's really interesting to remind remind ourselves that the light that we're seeing has traveled many, 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 in some cases thousands or millions of years. And even in our galaxy, if you consider, let's say even over, say 75,000 light years, you know, we're talking the earliest examples of human art. You know, so we hadn't even developed really good language skills yet at that point. The last Neanderthals, you know, the last glacial period. Then as we get closer, Rome found it, you know, and it's, when you're looking at a region of a sky, whether you're taking a photographic shot or you're visually looking, because of the way all of the objects are at different distances, we're getting kind of a differential time thing. And I only wanted to mention this because it's something that we don't always think about when we're observing the night sky, and I think it's kind of neat to just remind ourselves of that. Whoops. Okay. So, just getting back to the galaxy here for a moment, I will, oops, hang on, I keep hitting the wrong button. I terribly apologize for this. I'm still getting used to this thing. This is where we are again, roughly, and our sun orbits the galaxy about every 250 million years or so, okay? So we've done about, what, about 19 rotations roughly, I think, somewhere in that range since our star formed. And this has some implications here when we start looking at the, when we look seasonally. So right now we're starting to get into late fall into early winter, and predominantly our night sky, we're pointing away from the galactic core, and that's why we see a lot of star-forming regions, okay, like the Orion Nebula, and a whole range of clusters all throughout M45, and throughout the whole region of that sky becomes very prominent at this time of year. As we get into spring, we start to tilt away from, if you'll remember that diagram I showed with our Earth's orbit, we start to face away from the galactic plane a little bit, and now we start to be able to see more galaxies because we're removing ourselves from the noise, I guess you could call it, of our galaxy. And then we see a lot more globulars as well, so that's why we have good Messier hunting times, obviously. And then as we get into summertime, we're starting to orient ourselves more towards the galactic core, and unfortunately with visual wavelengths, whether we're taking photographic images or visually observing, unfortunately we're, whoopsie, hang on a second, I want to hit this button here. We actually have a bit of a blind spot at visual wavelengths. Now some of the new infrared telescopes that are, and techniques that are being used are able to penetrate beyond here, and we're starting to learn a lot more, not only about what's going on in the core region, but also beyond it. So we get about, I guess, 85% of our galaxy is visible, and then of course beyond the galaxy, of course. But it's just important to remind ourselves this when we're looking at certain regions of the sky seasonally. Now I'm not going to get into coordinate systems tonight because we're talking about visually reckoning the sky, but I just wanted to remind everybody that for those of you that are a little newer, we're actually, even though the Earth rotates from east to west, like we're always used to things rising east and setting the west, but actually our Earth is rotating the other direction, okay? So what implications that have is if we're inside this ball here, if you will, looking towards the north, the sky is rotating counterclockwise. So just remind yourself that when you're looking at the sky, okay? Now, I'm going to talk a little bit about, I'm going to be using these planispheric charts a little bit. This is Polaris in the middle, okay? And for those of you that haven't seen a planisphere before, basically what we're doing is we're taking the hemisphere of stars that's visible around the sky and we're projecting it flat. This is not unlike what happens when we take a globe and project it sort of on a flat Mercator projection, okay? You get some distortion, unfortunately, but there's no way around it. So we're basically looking straight up here, and if I was to hold the chart upward and face south, I know I'm not necessarily facing south right now, but I'm facing you guys, let's say you're south, north would be behind me, and east and west would be in the correct orientation, okay? Now, as well, we normally would have this sort of oval here, which would be anything inside of this is visible and above our horizon. Anything outside of that would be below our horizon at the time. The reason for the distortion is because, again, you've got a projection issue. There's a little bit of distortion, and it gets a little broader as we get out towards the edge of this diagram here. Okay. And what we would normally do is you can see the you know, May, April, March, and so on. So as we progress throughout the year, this moves Now the other thing that a lot of people maybe don't realize, or maybe you do, we reckon time differently. Our solar time is the time for the sun, like say noon to noon. Our solar day will be when the sun is reckoned at the meridian. So each day we wait until the sun comes around again. But because our Earth is rotating in the same direction that it's revolving around the sun, we actually have to rotate a little longer in order to have the sun in the same position. The stars and other celestial objects a long distance away normally show up about just under 4 minutes, 3 minutes, 56 seconds or something like that, and then some fraction of seconds, of course. And that's our sidereal day. So because we lose almost 4 minutes a day, if you add that up, say the average month is 30 minutes. So we lose about, on average, about 120 minutes or 2 hours a month. Multiplied by 12 months, that gives you 24 hours. So we actually, this is why we see the constellations sort of process or progress seasonally throughout the year. I just wanted to remind everybody of that as well. I probably should have had a diagram for that, but now this particular one that I'm using, I got on Astronomy Now, and this is actually a really nice planisphere. For those of you that are trying to learn the sky a little better, this thing's almost 2 feet square, and I got mine laminated. It's about $13 at Staples to do it. It's a little pricey, but the nice thing is that it doesn't get damaged. You can roll it up, and then you can roll it back out, and you can see everything. There's a little close-up here for the autumn section that I thought would be of interest, and they feature some things on each corner seasonally what would be interesting to look at. And then, of course, you can see here a little bit. I apologize to the ones in the back. Maybe I should have made this a little brighter, but you have some of the bright stars, and then they have the constellations laid out and so on. And a few brighter Messier objects, just to kind of give people an idea of how everything's laid out. They're really cool. Now we're going to get into the meat and potatoes of this. So what happens when we do star hopping is we use familiar bright stars as well as asterisms composed of bright stars. And one of the most common ones in the northern hemisphere is the hello, keep doing that, sorry guys. The Big Dipper here, okay? Everybody's familiar with it. Just to give you a relationship here angularly, this kind of gives you the spread for this particular asterism in Ursa Major, the Bear, okay? And of course, we're all familiar with the pointing stars going to Polaris. It's about 28 degrees from Zero to Polaris. And I just threw in an average standard binocular field of view for 10 by 50 binoculars, just for reference here. Now, because we are looking at varying regions in the sky, we don't always have the Big Dipper handy to kind of gauge everything. So just keeping this in mind from before, we can also use these as sky measures to be able to estimate angular distances. So as an example, if you hold your arm out, you can use your pinky, and that's about 1 degree, okay, approximately. And your 3 middle fingers, some of you may have seen this before, but that gives you about 5 degrees. And your fist is 10, and then the index, and you're almost doing a sort of a lightweight hang 10, kind of. Your pinky and index finger gives you about 15. So if you're reading in, let's say, a magazine like maybe Sky News or Sky Telescope, they're talking about something being, 5 degrees away from Mars or something, you could just use your 3 fingers and locate Mars in the sky, and then you can just go, okay, it's about there, and then either aim your binoculars or telescope to it. So this comes in really handy when we're doing reckoning. Not unlike what the ancient Polynesians did to try and determine the angles that they needed. Now in the autumn skies, just to review some things here, I know we've talked about this a little bit during my binocular talk last month, and I know Brian had talked a little bit about some of these things too during his What's Up last month. We have the Big Dipper in the lowest point in the sky, getting into the lowest point in the sky, but it's not below the horizon at this latitude, okay? Cassiopeia, the W asterism, is of course basically right across from the Big Dipper approximately, and it's in the highest position in the sky this time of thing, as you get closer to midnight. The Summer Triangle is starting to go to the southwest. Orion and Taurus is rising in the east, and we start to see it now earlier and earlier as we get closer to Christmas time, of course. And then, of course, the square of Pegasus was due south, and we talked a lot about things that you could find last month using the square of Pegasus, and now it's starting to get a little bit more to the southwest as time progresses. Now I'm just going to refresh everybody what sort of some of the general things that Brian and I talked about that you find using the square Pegasus. This is a little earlier in the year, but as an example, you can star hop over to M31, just following along here, and you can use a pair of binoculars, or you can, if it is visible from your backyard, or let's say if you're at a star party and you can trace everything okay, visually you can get up to M31 very easily this way. M33, you would just extend this down. It's a little bit below, and M33 should show in that region of the sky. The double cluster is just slightly off the page here, but you can use connect these two lines here, and you're almost right at the intersection for the double cluster. The Veil Nebula, the Veil Nebula complex, you can basically almost you go about a third of this distance on the front legs of Pegasus, and you can go right up there. And then of course M15, which is a nice globular, is right just off the nose of Pegasus. Okay, and this is essentially star hopping 101 in a way, because what we're doing is we're using these bright asterisms and stars, and I'll be reiterating this a lot of times during this talk, to find regions of the sky that we want to look at. Now in the winter time, as we're getting closer to winter, Orion will be closer to the meridian now. It'll be at its highest point at this time of year. And you'll see the Big Dipper rising in the east now. It'll be starting to be at eastern in the early morning. It'll start to be kind of towards the eastern, like northeastern part of the sky, a little bit more up, higher up in elevation. Oregon Gemini complex will be near the meridian. You'll have Pegasus starting to set in the west, and so the square will start to kind of slowly disappear as we progress throughout that season. And then Cassiopeia will start setting earlier and earlier in the western skies as well. Now, with Orion, the nice thing is you can use the asterism of the hourglass in the constellation of Orion as a guidepost as well. And again, this is how we do star hopping. Very basically, we can take, let's say, the top two stars here, able to use some Bellatrix. We can actually go about maybe 4 or 5 hourglass widths over, and we get to the tail of Cetus, the whale. You can also take these center stars here and project up and go to Aldebaran, which is the brightest star in Taurus. And then, of course, you've got a Hyades star cluster in here. M45 is up here. You almost go double that distance, and you're at M45. The bright stars of Castor and Pollux for Gemini. Again, you just kind of go on a diagonal here, and you can find them very easily. They're bright enough that you can see anyway, but in case you're trying to learn the sky, or you're trying to, let's say, estimate how far you need to go, and maybe there's something in here that you want to look at, you can do that very easily. You can also take the top two stars here again, and get to Procyon, Canis Minor, and again over to Sirius. So the nice thing is here, because we have access to very bright stars at this time of year, Sirius and Procyon, you split the difference in this whole wedge here, you've got Monoceros, right? So it's really nice to have access to some bright stars at this time of year. Just below the hourglass here is Lepus there. Okay, so again, you can use these as guides. I like to call these almost like stellar compasses, if you will, because the patterns in the stars you can use to project out to other regions of the sky of interest. Now, the Big Dipper, as it gets more prominent in the late winter and early spring, it's probably one of the best asterisms to do this kind of star launching, because you have access to almost the whole sky at varying times of the year. So as an example, I mentioned Cassiopeia being almost the polar opposite of where the Big Dipper is. You can see it here, it's almost juxtaposed here across Polaris here. We can use the pointers, obviously, to go to Polaris and find the Big Dipper in here. We can use the top part of the bowl here to go over to Capella. You can go angularly across and head to Castor Pollux. You know, you can see all these relationships here. It's very neat, because these bright stars, I recommend that anybody that's learning the sky, and even if you have a go-to telescope and you're like, I don't really need to know all these stars, how are you going to align your telescope? You know, if you happen to align on the wrong star, your telescope's pointed in the wrong direction, you're going to have trouble finding things. So I really recommend, for those of you who are new in the hobby, to try and learn at least a dozen to 15 of these bright stars in varying regions of the sky, because then it makes it very easy to start navigating around the sky. Okay, and also align your telescope if you do get let's say, go to down the road. For those of you that are more experienced, good idea to maybe have a refresher course, because we all get lazy. You know, I mean, now with the advent of cell phones, and I mean, I used to be able to remember every single phone number. How many of you now do that anymore? It's always on speed dial, right? So, you know, we all do it, I think. Now, the only reason I brought this up, I just wanted to sort of point out here, if we're looking at this sort of more close-up region of the sky as we get into, you know, late winter, early spring, certainly in even the mid to late fall, this area of the sky is up high enough to look at too. We've got several different star clusters that are very easy to find. And there's a couple of different ways to hop to them. You could walk your way through the star fields with your binoculars, say as an example, or your wide field or finder scope. Another way you can do it is to use those handy hand gestures that I mentioned earlier. So say as an example, if we're looking at Capella, you've got several bright stars. Capella is a really bright constellation. If you're trying to find, say, M38, you can look along the diagonal here and just walk your way through, and then set your binoculars where you're trying to aim from. And it doesn't take very long to hop to these. They just fit, you know, like M38 and M36 are very easy to spot right on the edge of a field of view of, let's say, a 10 by 50 pair of binoculars. You're right on the edge of there, so it doesn't take much to go to the next one and so on. M35, same thing. You can either start at the bright stars here or even at Alhena and slowly move over until you start getting these other stars. Or you can walk your way down one of the twins here, down their lake, and go on from there. So there's different ways to do this kind of searching, and it just depends on what's easier. If you happen to play around sometime with techniques like this and you discover a really, really easy way of doing something that's easy to remember and makes sense, like I said, there's varying ways of doing this. Let us all know, because you know what? We might end up learning something too. This is the kind of thing that's always being refined. Now, as we get into spring skies, we get Leo basically on the prowl towards the south now. We have Ursa Major and Boat is up right towards the meridian now. And that makes it easier when you think of how the orientation of those stars were around Ursa Major now. You can use those as launch points to look at various regions of the sky, right? Oregon Gemini Complex are setting in the northwest now. We're starting to see Hercules and Ophiuchus rising in the east. And Coma Berenices is high up, and now we're starting to get into our galaxy time, because now this whole region in here is full of galaxies. Now, if you look at this this little cloudy region, and most people are familiar with this on star charts and so on, that's our galactic plane. So what's really interesting now is we're looking at this time of year away from the galactic plane predominantly, and that's why we see a lot of galaxy clusters and stuff very easily, as well as globular clusters, right? They're very, very prevalent at this time of year. And the brighter ones, of course, have Messier numbers on them, and of course, Messier hunting is always done usually in the mid to late spring. Quite often, you can bang off a good majority of those objects. Now, we were talking again about Ursa Major, and I just kind of wanted to remind a couple of other things that I've done with Ursa Major as well. These are little sort of mnemonics, if you want to use them to remember how to find things. So the handle here of the Big Dipper asterism, you can arc to Arcturus, and Arcturus is a nice orange yellow star, Alpha Boötes. Okay, so I never know how to pronounce that constellation. I would say Boötes, but anyway. You can then spike to Spica. That's another one I always pronounce funny, or Spica. And then, of course, Leap to Leo. And if you think about it, these three bright stars here actually form kind of almost a spring triangle, if you will. So you could even use this combination a little bit. They're fairly spread out, but you could use them kind of as a spring equivalent to the summer triangle. Now, of course, we've got our pointers here aiming towards Polaris, just to give you some orientation. I always find the easiest way to find the head of Draco, especially in a more light polluted area, or if I'm at a very dark site and there's just so many stars, sometimes you can get lost. I find the easiest way to do this is I usually take the bottom part of the bowl here and just go right across here and then project over, and then right near the head of the dragon. It's quite a jaunt here. If this is 28 degrees, you're probably looking from here to here about almost 40 to 45 degrees, but it's one way to do it. You also have some other dim, well, I'm going to talk about like Coma Berenices as an example. We have a nice way to find it as well. You take three of the brightest stars here and just go straight down. Again, you can get to Coma Berenices. This is fairly early in the new year kind of thing as we get into our spring skies, but as things start to progress up, these are much higher up in the sky towards the southeast. Okay? And then of course Leo, you know, you can also take these two stars here and project over, and that gets you to Regulus as well. So you can do either way. Is fine. I mean, Regulus is very prominent, and Leo is a very prominent constellation as well. What's nice in this region of the sky, I mentioned about some galaxies. I mean, there's lots of objects in here, so I don't have time, obviously, in a half an hour to talk about all of them. But some of the more prominent ones, like the Leo triplet, you've got 3 galaxies here. And the easiest way to do this is just to, if you found Regulus in the main outline of the lion, you just go basically to his hip and to his hind leg, and right halfway in between, especially with a pair of binoculars, you'll find it very quickly. You can also find the lot 111, which is a beautiful star cluster. It barely fits into a field of view of binoculars. It's very expansive. And I find the easiest way to do that is, it's almost an equilateral triangle to get to the edge, but you can just do a little isosceles triangle and you can get right to the middle of the cluster. And then of course you can then get into some of the more esoteric objects. You can walk your way down with binoculars, say, or a wide field scope, and go along Coma Berenices, and you can find these two Messiers very relatively readily in a dark sight. And of course, we were talking about galaxy time, so besides the Leo triplet, if we extend down near the end of the handle, we have the M51 Canis Venatici, and we have M101, almost equidistant from the, like if you extend the arc from Mizar Alcor straight across here, you're right in the region for M101. Okay? And then I find the easiest way to find M81, M82 is to take the diagonal here and go the same distance. I just didn't have enough room to do this on this slide, so you just go the same distance out and you're pretty much right in the region there. So this is the way this is the way we find these kind of areas to observe things. And this is, in essence, the art of star hopping. Okay, we're taking common asterisms as our launch points, bright stars as references, and we're using them to find our way around the sky. And as you practice this and get better at it, it becomes second nature, and it becomes easier and easier. Now, as we get into summer skies, we have Pegasus rising in the east. The summer triangle is pretty much up all night now. You have Arcturus in the southwest, Ophiuchus is at the meridian, and I have Hercules Corona Borealis here overhead. Now, the nice thing with the summer triangle, for those of you who are a little rusty of what it is, basically we're taking three of the brighter stars that are up overhead, near almost perfectly overhead in midsummer. Vega, Deneb, which is the tail of the swan, and Altair. Okay? And this forms a very, very easy to see triangle. Very expansive on the sky, but very easy to see. You can use it as a reference point for several things as well. So as an example, if I want to look for Lacerda, especially like Lacerda isn't one of the brighter constellations, obviously, and it's near the edge of the Milky Way. Whoa. Let's stop this here. Let me go back. Sorry, I hit the wrong button again. One of the challenges here is that trying to find the actual constellation line, especially from a really, really dark site, is it kind of gets lost because there's just so many stars. And a lot of the stars that are in Lacerda are very, very, they're not quite as bright. So, I mean, you can make it out certainly, but it starts to get washed out in the Milky Way. So the easy way to find this, or if you're, let's say, in your backyard and you've got a little bit of sky glow, again, it's the opposite effect, but now you don't have enough sky, you've got too much sky brightness to really pick it out easily. You just go about 2/3 or 3/4 the way that these two stars are, and just extend over it to get to a certain very easily. Same thing with Delphinus, another constellation that's very dim, but you can use the orientation of the bright stars in this case Altair and Deneb, and almost a right angle triangle, and you're right at the corner of that right angle will get you to that constellation very easily. We can also walk along Aquila to get to Scutum if we needed to, and there's lots of goodies to do all along here. So I'm not going to get into all of those because of time constraints. Just to remind everybody, this is what our 6-degree field of view for binoculars would look like. And obviously, if you're using a dome with, let's say, a 1-degree field of view, it makes it even more challenging to do your hopping, right? It's another reason why I said last month that binoculars are a really, really essential tool for observing, because not only for learning the sky, but sometimes you can pre-pan with your binoculars to make sure you're in the right area before you set up your telescope and aim in that direction. Now, some other things that are in this region of the sky, I'll just mention this very briefly, we're just about at the end here. Obviously, for those of you who have heard of Alberio, it's one of the easier to find visual doubles. In some cases, if you've got good visual acuity, it's kind of pushing it. But certainly in a pair of binoculars, very, very beautiful double star. You've got a beautiful golden yellow primary with almost a sapphire blue secondary. It's very vivid, contrasting colors. And it's worth taking a look at if you've never looked at it. And it certainly looks good in a telescope as well. Actually, almost better in a telescope than in a pair of binoculars in this case. But I use Alberio as a launch point to find M27. Many of you guys do. For those of you that don't know what M27 is, that's the dumbbell nebula. Okay. And what I basically do here is I take the approximate distance between these two stars and Cygnus, and I just transpose this over, and I'm almost bang on every time, whether I'm using binoculars. Yes?
I find Sagitt's fairly easy to find, and if you go up about the length of Sagitt's up to the left and angle slightly, you get to M27, and you go up to the right and angle slightly, you get to the coat hanger.
Yeah, and in fact, this is sort of another way of looking at it. I was just going to mention the coat hanger here, and I just find it very easy to do it this way because because you're already gauging the stars. I mean, you're right. If you're using a telescope, that's probably a better approach because you've got a narrower field of view and you can walk your way up. Sagittarius, you're right, absolutely. With binoculars, though, it's almost easier to do it this way in some ways. Like I said, there's more than one way to skin a cat with these approaches, and thank you for bringing that up, because there are different ways to do it. I just found this a very convenient way to do it, especially if I'm observing from the backyard and I'm having a little trouble with sky glow or something. This is a much easier way to do it. Sometimes M27 doesn't stand out quite as easily from a suburban sky, right? So anyway, thanks for bringing that up. So anyway, in a nutshell, like I said, really what we're doing with star hopping is we're dead reckoning the skies, learning where things are, and we use the bright stars as guideposts. That's basically all it is. It's a very, very simple approach to things. We use them as markers, and of course alignment points if we're aiming our binoculars or telescope, and also to align our go-to mounts. And then we use the larger bright asterisms, and I gave several. We have the, just to refresh everybody's memory, I mean, we have the Big Dipper is the most prominent one, of course, and then I also mentioned the Great Square of Pegasus that we can use as a reference point, the Hourglass for Orion, and of course the Summer Triangle there. Okay, these are I use these as sky compasses to kind of orient around the constellations and to project off of to other areas of the sky. So in a nutshell, that's basically what star hopping is. I'll probably do a follow-up down the road with more, kind of in line with what you were mentioning, where we go to discrete regions of the skies closer up, and then how to walk your way through. But the purpose of this one was just to reintroduce, or at least introduce to some of the newer members, the concepts behind it. Okay. So again, continue to learn the skies, ask questions, and keep looking up. That's basically it today. Thanks for your attention.
Thanks, Darren. That was great. Yeah, one of the things that I have really found, as I've gotten older, is when I go out, I actually go back to a lot of those things just to get myself situated, right? Like just do a quick, okay, yeah, from there to there to there to there, and just get myself oriented. So those, Darren's totally right. Those are things that they're going to become second nature. But they're not, like, the process that you're going to go through is not like, well, I'm going to learn this beginner stuff and then throw it away. No, this is foundational, right? Like, this will stick with you for the rest of your life. You will continue to use those skills as you're trying to find your way around the night sky. So, and I'm sure Dan will get into this in future beginner sessions, but they really build in when you're trying to hunt down, the faint fuzzies and using those star hopping skills in those areas. The other thing it's really nice for is you can think of, when it's really freaking cold out, and you're, bundled up, around your telescope and you're looking up, you can think of those Polynesians out in the Pacific Ocean and how they star hopped along through the night sky in their lovely tropical weather. Anyway, so but yeah, no, I don't know. I'm passionate about it because I think that star hopping is a really good skill to have, and it is very important that if you're getting into this, you need to learn it. So, but that said, my name is Brendan. I am the still president for a couple more months, but we will be having, and I'll talk about that. I'll talk about that a little bit later. Is there anybody else? Is there anybody here that is here for the first time? Newbies? Hi. Hello. Welcome. You seem to have friends with you who know what's going on, but that's cool. If you want to know more and they don't have answers, feel free to come talk to me. And if you're still new and you have any questions, I am usually found at the break, standing up here talking about the club and everything like that. But yeah, for tonight, so we just had our wonderful Star Hopping Made Easy beginner session. We're currently partway through me yammering on about announcements and whatnot. Brian will be giving us a what's up and a Glenley Observatory update. He's been working on a lot of stuff over there. Made a lot of improvements, and he wanted to share what he's been doing there. And then I will be giving you a what's new in the science of astronomy. We'll take a break for refreshments, and Alan Macklin will be giving us a talk on astrotourism. So if you like to travel, one of the things that I have found is that there are a lot of really neat places out there that you can go and explore if you're into astronomy. And a lot of them don't actually get a lot of tourists. Some of them do, but a lot of them don't. So there's some really neat stuff out there, so he's going to talk a little bit about that and some other stuff. So, green laser pointers. This came up in discussions at the national level. So we are the Winnipeg Center, and then there's a national level above us, below us. I don't even know, whatever. And this has been going back. This has been going back and forth for a while, and I won't get into all the details of it. But effectively, Transport Canada has laid out some rules about green laser pointers and their usage, and I just wanted to try to convey that information and get the facts straight. What the kids call TLDR, too long didn't read, is basically we're fine. There's nothing to worry about. If you're using them for educational or astronomical purposes outside of an area that I'll talk about in a second here, you're fine. We really don't have anything to worry about. But if you want to know more, this is basically what they've come out and said. So again, with some exceptions, it is now illegal to possess a handheld laser over 1 milliwatt. This thing better be not over 1 milliwatt. I'm saying over 1 milliwatt in public areas within municipalities within the Greater Montreal, Toronto, and Vancouver regions, and within a 10-kilometer radius of any airport and certified heliports. You may possess a handheld laser anywhere in Canada for any of the following reasons. The laser has a 1 millimeter or less. Who cares? We really don't care about these. You are in possession of the laser for a legitimate purpose, such as for work, school, or educational purposes, or you are a member of an astronomical society. Hey, that's us. And are in possession of a laser for that purpose. Yeah, so I mean, just because you're a member of the RASC, if you're shining these at planes, that don't count, right? Legal, whatever. They try to cover all the various things.
Do we have to carry a card?
So, there is actually a process where you go online and you submit a form to do a thing. There's a camera on me right now. It's going to be recording this on the internet, but I hope nobody hears me say this. I don't think anyone is looking at the damn things, right? I think you're fine, right? Like when we are out in Riding Mountain National Park, we're shining these green lasers up in the, we're doing public outreach out there, And so I cleared it with the national park, and like they said, yeah, it's fine, it's cool. You know, like their internal guys said it's cool. Stan?
I was going to tell Alan not to worry about it, because if you're arrested, you'll still come visit.
Thank you.
What, sorry?
Yeah, there's plenty of room in a Astronomer prison. I don't know. So so to be clear, right? Like this is there's a couple things going on here. You know, some of it political, some of it not. But really, at the core, I mean, what they're trying to do is they're trying to have some kind of framework in place to punish people who are taking these green laser pointers, these powerful lasers, and shining them at pilots that are trying to land or take off. Right? That's the core of the problem right now, is that pilots are getting, like, not actually, like, if you've ever seen the picture, actually I should have brought it up here, but there's a picture of a cockpit that's been lit up by a green laser pointer. It's really distracting, right? Now, obviously, we're not doing that, and there really shouldn't be any issue. I don't, you know, if somebody stops you over it, which I believe to be highly unlikely, I think you'll be able to work your way through the process. I wouldn't worry about it too much. So, sorry, it's way bright. Maybe I should get fined. So now the one thing that Transport Canada has done, which I was really impressed by, because you don't really see a lot of good web technology on government websites, but I mean, it's relatively good anyway. I mean, if you just search for green laser pointers, Transport Canada, you'll find this. Don't worry about saving this URL. I just wanted to give you an idea of where it was from. They will actually give you the 10-kilometer radius. So basically, anywhere within here, right? That's like the no-shine zone, right? Basically. Now, again, keep in mind, yeah, so you can do it, you know, you can do it for these reasons, but yeah, these is where you don't, like, outside of here, you're okay. In here, you're not. So we're generally fine for the most part. So, yeah. But this also includes, like, this will include the Brandon Airport, the Gimli one further north, you know, so that sort of thing. So anyway, but if you're, in particular too, like, if you're traveling, you can pull up this map and just have a look and just make sure that you're cool. So that was my little.
Well, Okanagan Marsh is out of that zone, and so is Glenlee.
Yes, that's a very good point. So we're yeah. So Okanagan and Glenlee are out of these regions. There's nothing down at the Nature Conservancy. They're out in the middle of nowhere. You know. So generally, I mean, and that's the thing too, right? Is that, like, where we're going to be where we're actually going to be using green laser pointers to do this sort of thing, we're generally going to be out of those regions anyway, right? In a city, trying to show people things with a green laser pointer is, I mean, it's kind of useful, but for the most part, you're just going to be saying, like, oh yeah, it's that bright point of light right up there, right? Okay, so that was the not so fun part. I had to change the title of my slide. I don't even know if it's true anymore, but I used to say calendars for sale. Apparently, it's only one left now. One left. Stan's got a calendar. If you want a calendar, you can give him $13. $13 inflation. Yeah. So give him $13. He'll give you a calendar full of a bunch of really pretty pictures. One of them from a Winnipeg member, Kevin Black, and yeah, there's good stuff in there. This month, as with every month, there is a U of M open house. These are held here, not in this room, but at this university, in University College in room 240, for the last Wednesday of every month. Danielle did not have a topic up on the website, so anyway. But the last one was like dark matter and spooky Halloween theme. She was going to do one on Pluto, I think, in October, so that maybe got bumped to November. Who knows? But yeah, if you go, she's a really good presenter. There's a lot of interesting stuff that gets talked about, so I do recommend it. And they do go and do some observing if it's clear. So she's always happy to have some RASC people up there as well. Speaking of happy to have RASC people, Okanagan, as we were talking about, they do their thing. On third Thursday of the month, I think. And yeah, so the next one's coming up next week, on the 15th. So, want to be clear? What's that? Is it going to be cloudy? I mean, probably. In my, I don't know. Yeah, if I was putting bets on it, but yeah. So if you want to head out there, we have members that go out there pretty regularly for these events, and they're fairly well attended, especially in the wintertime. I think things get cold and people are, I don't know, get cabin fever or something maybe. Telescope loans. We have telescopes that you can borrow from us if you're a member. So this is one of our several member perks. We generally loan them out for 1 month at a time. There are 2 8-inch Gaussians. There's a solar telescope that you can use. Of course, the sun is a little bit quiet right now, but it's still worth it. Well, actually, there was some activity recently, so worth checking out. And you get it for a month, so you're bound to get a clear day or night occasionally. Right? Yeah, Stan, what's the current status?
They're all available.
Okay.
I want to remind everyone that some comments are coming into some brightness this month of December.
Yeah. So we do have, so we got some comments coming up, and those 8-inch knobs would be probably pretty good for them. Cool. That's a look at our loadout. I was also going to say too, this the solar telescope also comes with one of these Ioptron. How can we call it? Skytracker. Yeah. And these are great for they're lightweight. They're lightweight trackers. So I would even say that if you wanted to take one, and I think whoever took it out last month, I think actually may have tried to use it. Anyway, but it was a really good idea. If you want to get into a little bit of wide field photography, this thing is really great for that kind of stuff. So there's other options in there as well for it. On the observatory, I won't talk about too much. Brian wanted to present on it a bit. So this is our observatory south of the city. It is outside of the 10-kilometer radius that I was describing before. We have a warm room there. We have a couple telescopes that are free for you to use. I recommend checking the place out. You can see Brian for details. And explore the universe. So Dennis Lyons, one of our members, has been, he's also our national representative. He has been promoting this Explore the Universe program. The feedback into Darren's beginner talk, it's a really good opportunity to go and try and use those skills. Much of what you would need to find in order to complete this certificate, I would say he probably covered like 90% of it, in that beginner session tonight. So a lot of that basic star hopping that you learned, that allows you to see a lot of the night sky, and this is a really good directed way to get you out there looking at stuff. That's all I had. Does anyone else have anything they wanted to mention, club related? Okay, cool. Oh, I wanted to mention one thing. Sorry, Brian. I know you're slowly walking down. Just walk slower. Let's do it. Council. So the people that organize that run this club are composed of it's like 5 or 6 councilors, a treasurer, a secretary, vice president, president. I think it's everybody. And then we have some appointed positions like our national rep, our webmaster, etc. So in January is when many of our terms are up. So we are looking for people to come on board and participate. Now you won't be alone. A few of us will be sticking around for sure. I am obligated to stick around because I will have to fill the past president role because I give that to anyone. But yeah, so I mean, I will be there. I don't know if that makes it feel better or worse. If it does, I could not join council. That'd be fine too. Whatever works for me. But I think it would be a really good opportunity to try and get some more. It's a really good opportunity to try and get some more involved. So I mean, if you've thought about taking a more active role in how the club operates, how the club spends its money, whether a web forum or an email list makes more sense. This is your time to shine. This is your time to come on board. So if you're interested, contact. You can do a couple things. You can either Jay is the one officially putting together all of the nominations. If you want to talk to me, that's fine too. You can shoot me an email if you have it. If you don't, use the contact form on the website. Just let us know if you wanna be involved. So that's my pitch. Also, you can nominate others. So if you think somebody would be a good candidate, you can throw their name at us. Totally serious. Now, I mean, they don't have to accept it, of course, but we'll try to persuade them. So, okay, anyway, that was the only thing I wanted to say about that. So, Brian, you can now continue on. Yeah. Yeah. Oh, yeah, real quick. We will be, sorry, Brian, so, one of the really good skills to have as a president of a club like this is organization. I got none of it. So I don't know. Yeah, I sent out an email about the astronaut Dave Williams showing up at McNally Robinson. How many people went to that? I couldn't make it that night. Okay. Yeah, decent number. Good. Fair enough. Yeah, so he was there talking about his book and signing books, and one of our fine club members, Gail, wanted to donate a signed copy of the book to one of you. So in order to make that happen, we will be doing a draw at the break. Chris, with the help of some people, I think we'll probably you can just come grab a ticket, I guess. Yeah, go see Chris, he'll give you a ticket at the refreshment break, and then we'll do the draw after that. So, okay. Now you can go on. Oh, except for the one. Kidding. I had to. The trick to comedy is when they know it's coming. Oh, you don't? Oh, okay. Okay.
Thank you, Brendan. You want to hear me? Okay, so, I'll just want you to know me. I'm Brian. I'm also director of Glenley Observatory, which I'll talk about a little bit later. So, what do we have up for the next guy of November? We'll talk about it. Good. Wait. Oh. All right, a little too much there. Maybe I'll just have this thing here. Okay. So, anyways, we'll talk a little bit about the planets. Unfortunately, it's actually playing. All right. Anyways, we'll talk a little bit about the planets. Not much is really happening in terms of planets. The only one really visible in the evening would be Mars and Saturn, but unfortunately, Mars is out of reach right now. At least I think so. It's just too far ahead or past us for Mars. So not really good. The rest of the planets, of course, it's only going to be visible mostly during the day. Jupiter's kind of iffy, but unfortunately that's all we have for planets. Okay, so what do we have in the evening? This is for tomorrow. If I had a members' night tomorrow night, I might reschedule it for Sunday, but I might host that meteor shower on Sunday as well too. So I'll keep you guys posted on that. So that's for tomorrow in the evenings. Like I said, we have Saturn right here. Also want to mention this because it's right close junction with the moon right here. And of course we have Mars should be right there. Just kind of give you an idea, but of course it's quite early in the evening. So unfortunately that's going to be all disappearing really fast. Now, what do I have here? I was supposed to talk about one constellation because I talked to Darren earlier. I was supposed to talk about one constellation, but I'm going to talk about a couple actually. And if we have members tonight, and I might, like I said, schedule it on Sunday, I have 3 constellations in mind: Hercules, Lyra, and Pegasus. And I picked those for a number of reasons. One, well, they're relatively easily to find for me. I don't need a computer to lock onto it. I can just point in telescopes and there it is. 2, they're ideal for new members, because I know we have a lot of new members here, so this would be an ideal object. So I'll point out just quickly what I'm talking about. There's Hercules up here, and of course we have M13 and M92. Those are star clusters and they're really nice to look at. Next, we have Lyra, and then we have M57. Pointing where it is. So again, I don't need no computer to tell me where it is. It's really easy to find, but it's, again, nice for new members to have a look at. And the last constellation, well, Pegasus, not the last, but Pegasus is a nice constellation, of course. Darren did talk about earlier and how to find it. We have the Andromeda Galaxy, right about there. Of course, that's early in the evening, just for starters. We do have, you did talk about Orion later on, but it doesn't rise until roughly about 12:30, I believe. Okay, next. Okay, what do we have for events in November? Well, we have a number of meteor showers, and I didn't mention the comet. I'll tell you more about that comet M45 that's coming up. So, like I said, we've got 2 meteor showers here. We have the south and we have the north. The north is coming this Saturday, or this Sunday, sorry. It's going to peak Sunday morning. So that's why I picked Sunday. So if everything works out, weather does look like it's going to clear. So hold your breath. So we might get lucky, finally. But we'll have to wait. And of course we have a lunar meteor shower that's going to peak on November the 18th. But unfortunately, it's pretty close to the full moon. So I might be hosting that, but Leo doesn't really peak until like 2 o'clock and it starts to rise the constellation. Okay. Now we have the north and south. We already had the south back November the 5th. And coming this Sunday, we have the north. What's so special about this meteor shower? Well, one good thing about it is the fireball to happen. There's only 5 per hour, but if you do catch a really nice one, you get a nice little big fireball in the sky, so it sets apart from the rest of the meteor shower. I did say I should be hosting it Sunday, November 11th, right? This Sunday. Weather does look promising. Of course, it's more the morning of November the 12th, but I'll keep you guys posted. Okay, the lunar meteor shower. Okay, well, when I did the research, the book says 20, the internet says 40, so that's why I put 20 to 40 meteors per hour. Unfortunately, we do have the full moon on the 23rd, but it's going to set around roughly 1:50 a.m. So I'll see. You may want to stay up for it if it's a clear sky, but we're not getting that many clear skies this year. So if we do get it, I might take the advantage and go out. Okay, now another thing I kind of found interesting was it peaks every 33 years. So the last time it peaked was 2001. So it's not going to be as big as it was in 2001. Okay, of course it's in the constellation of Leo. Like I said, I might host it, but I'm not going to start till maybe around 11 o'clock, but then we have the moon to compete. But we'll wait and see. Okay, where is it? There's Leo, the constellation of Leo. Like I said, it's not going to rise around 2 o'clock in the morning. Just kind of give you an idea of where it's supposed to radiate from for some of the new members. Okay, now we have this comet, 45P. I've been waiting for this all year. Drawback is it's winter time. And of course, it's in the evening, which is nice and easy for everyone to have a look at. Its magnitude is supposed to be projected at 6 around mid-November, but of course in December, It's going to get high as 3 or 4. It should be naked eye, but we'll have to see it. But of course, I said right now binoculars viewing because with the magnitude of 6, I would recommend using binoculars at the time until the magnitude gets a little higher. Now, it's approaching Earth. Next month, I want to mention it now because next time we have our meeting and I do the what's up, that's pretty late. So I want to mention it now. So, where is it? So, roughly, we'll say, well, I said about, what, almost 11 o'clock, roughly. This is south right here. That's where the comet 45P should be. But that's the highest it's going to get on November the 15th. So, but as later in the months, it's going to go higher and higher and higher, up to Pleiades. And I'll show you where it's at. So, that's where it's going to be, November the 15th. That's the closest approach it's going to get to the Earth. There's Pleiades, there's Taurus, the constellation, so it's right about there. In December, yeah, December 15th. And I kind of noticed it's almost the same time too, so again, it's almost like taking south and going straight up almost. It's going to be almost going straight up from 10:30. And that's all I have to say. Thank you. Oh, I do want to touch on a little bit about Gwen Lee. Next month I'll go in greater detail about all the work that we've done on Gwen Lee, but I just remounted the telescope on Thursday. Some of you may know that we're making it fully remote from the warm room. And of course you can control the LX200 from the warm room as well. And the goal is you can do your photography from the warm room or from within the dome itself. And I'll set up nights for the new members. If you come out there, I'll have all the adapters, I'll have the guide scope, and I'll show you just roughly, nothing complicated, nothing, free software to use to stack images. We'll use my camera if we have to. And just kind of give you a rundown of all the work that we've done in Lee. If, like I said, if Sunday holds really nicely, again, any new members that does show up, and I'll give you a little tour of Glen Lee. But there's a lot of work being done on it, and I hope you guys like it because it's been a while since I've been trying to get this going, where we can just remote control from the warm room. We have a lot of new software. We do have a coffee maker there, and we do have a lens cleaning kit donated by Darren, and there's binoculars too that we have for Glen Lee. Again, next month I'll go into greater details of all the donations I've been receiving over the years and all the work we've done. All right, thank you.
So you all know what it means when you can control the dome remotely from the warm room, right? You don't have to go inside. Alrighty. Sorry, Kat. Okay. So next on the agenda, that's cool.
You're back.
Yeah. I'm sure it's fine. Oh, shoot. I think I know what that might be. Okay. Something might not work, but I'll leave it to you to figure out what it is. Okay. So yeah, Ian unfortunately couldn't make it tonight, so I put together this month's What's New. So, preface, I am not an astronomer, like not the professional kind, so. Okay, so basically I'm gonna tell you a few stories going on in the science of astronomy. With this first one, it's the one time I'm gonna try and do the thing that Ian does, where he gives a clever title and you're supposed to figure out what it's talking about. It's really not that clever. So does anyone have a thought about what this is? First, that's the moon. I'll give you that tip. Okay. Does anyone have a thought about what that is? There's a hint in the title.
Boy fishing on the moon.
So, moon, cows, milk. That is the Milky Way in radio waves. So that was elaborate. There, I told you I wasn't good at saying it. So what this is this is actually the Milky Way that reflecting off of the moon in radio waves. And now this wasn't actually this isn't what they were trying to do. It actually was just a good candidate. What the scientists are trying to do is calibrate their equipment to hunt for early neutral hydrogen as a way to learn more about the early universe. So this was just a way to try and test that out. They are using this the Murchison Wide Field Array, which is in somewhere out in Australia, and yeah. So that was basically what they were trying to do, but it ended up generating this this calibration piece ended up generating this really cool image. So yeah, I thought it was neat. And this is where I gave up with the clever titles. I lasted one, and then my creativity died out. So this is a supernova remnant. Actually, what you're looking at is the shock wave expanding outward from it. And so this was a supernova that went off in, spoiler, 1987, in the Large Magellanic Cloud, which is an object that we don't get to see from the northern hemisphere. It is something that you can see from the closer to the southern hemisphere and the southern hemisphere. And what was interesting about this one was that first off was that it's a blue supergiant, and at the time, astronomers models didn't allow for blue supergiants to go supernova, and they're still kind of trying to figure that out. So what that means though is that this supernova gets a lot of attention. So this image was taken just recently. But what's kind of neat, and this is. I think I gave away what I thought wasn't going to work. So sad. Okay, anyway. So the result of this was, what this was supposed to show you was that, so they'd actually been monitoring this thing since 1987. And there was a time-lapse put together. Where you can actually see the shock wave growing, right? And the brightness of it growing as well. And what's happening there is, there's prior to the star going supernova, it had actually blew off a whole ton of material and created these concentric rings. And so now that the star has gone supernova, it's actually working its way through those concentric rings and brightening that material up as it goes through, which creates this kind of neat effect that you would have seen in that time lapse if it worked, but it didn't. I'll see if I can pick up the video once we're done here, and then I'll see if I can show it later because it's just cool to look at. I mean, one of the things that I always appreciate is astronomy that actually has a little bit of time domain on it, because so much of what we do, I feel like we look at just static things, right? So to see something change over time is really impressive. Okay. Item 3. Oumuamua is in the news again. It's not aliens. There was a paper put out by a couple people from Harvard, which, I mean, it's cool. It's fun to think about. Okay, like it's fun to think about, but I don't know if there's a couple academics in there. But please don't do stuff like this. Like, or if you do, keep it really quiet. I don't know. It's really hard, right? Because what ended up happening was like I got so many messages from people, asking me. It's like, what? It's aliens? It's like, no. Because what's going to happen is, I should. There's a thing that happens in the news cycle, right? Because the actual considering this to be an alien spacecraft, There was a fairly well-reasoned argument behind it, which is there was no evidence of there being any kind of like outgassing or anything like that, right? And so what they were saying was, hey, this looks a lot like what we would be potentially doing if we wanted to have a solar sail. And if you've heard of stuff like Breakthrough Starshot, this is the kind of thing that they're looking at doing. They're looking at building these massive solar sail spacecraft and launching them with high-powered lasers. And this is something that it would potentially look like. That's it. That's all they said. I mean, there's more to it, a little more to it than that. That's all they said. But of course, the way that the science news cycle works is it gets picked up as it's aliens, right? And then I got to sit here and go, "It's not aliens." Anyway, moving on. So Mars Insight. So I kind of forgot about this little guy. But it's due to land on Mars on November 26th. So mark your calendars. This is not going to be like this is not going to be the crazy landing like Curiosity had and all that kind of stuff in the Mars 2020 rover is going to have and all that. Like there's going to be no drone crane drop or anything like that. But this is a really cool lander. It is going to be looking primarily at the tectonic and geological history of Mars. So the cool thing about that is that you can kind of plop this thing down anywhere and get interesting information, right? These are the various instruments. Heck if I know what 90% of those are. I mean, I know what a UHF antenna is. But I don't know much about the mission outside of, like I said, it's trying to study it's mostly going for the geology of the planet, right? So it's a very and very science focused in the sense of like I don't think there's a camera on it actually, So, but having a camera on it isn't really going to be all that interesting because it's not landing anywhere. It's really not landing anywhere interesting. So these are all the things we've landed. Well, we've landed on Mars. InSight's going to be over there, right? So now the selection process was a bit easier because they weren't looking to try and where you've got Curiosity here trying to go for these various trying to get a good geological record throughout the I don't know geology well enough to use the term, but I think it's like like the strata, like going up through the as you go up this slope, you can see the various pieces of history of the planet. Nothing like that. It's sitting there and it's trying to detect. It's trying to learn more about the insides of the planet. Right. So the selection process for the site. Well, I thought this was a good summary of it. If Elysium planatia were a salad, it would consist of romaine lettuce and kale. No dressing. There is nothing sexy or cool about this landing site. It is flat and boring, but that's what they wanted. They had a bunch of boring engineering considerations to take into account. Like it's got to be bright and warm enough to power the solar panels throughout the year, right? Ooh, exciting. And they also wanted it in a spot where landing it would not be dangerous at all. So this is just so to be clear, this is their landing target, right? So when you were coming in, I don't know if it's actually going this way or this way, but when they're coming in, they'll probably get it pretty close. They're getting pretty good at these things. But this is the plus and minus on where it could end up landing. And so there's really nothing of danger in here, right? When Curiosity was coming down, they had a whole bunch of checks and balances and sensors and whatnot to like look for any kind of like, oh god, like there's a rock, let's move a little bit further, kind of thing, right? So this thing won't have to worry quite too much about that. There's also there were also some considerations as well for being able to slow down fast enough because Mars is thinner atmosphere and all that good stuff. So. Speaking of spaceflight, asteroid bending. So the Osiris. So this is kind of a fun little time for exploring exploration of stuff beyond Earth, OSIRIS-REx, which is one of the weirdest names for a spacecraft ever, one of the weirdest acronyms I've ever seen, is going to be doing a sample return mission from this asteroid that has been named Bennu. And there's some neat stuff on it, like this guy here. What the heck is that, right? It's like it's like a smaller asteroid that has latched itself onto it or something. I don't know. Yeah. So this was this animation was imaged over a 4-hour, 11-minute period on November 2nd, and this is about from a 200-kilometer distance from the asteroid or so. So the plan is in about a month, they're going to get right up close to this thing, get some sample, and then bring it back to Earth. Summarizing a lot.
To be honest, Brendan, actually, the camera failed and all that stuff, and they just took a dust bunny and rotated it.
Yeah. If there's one thing about these scientific payloads, they do not really seem to go for the high def cameras, right? Yeah. So it is a little fuzzy. I mean, I could have probably just put a dust bunny up there, and you guys wouldn't believe me anyway. Speaking of what it looks like, I play a lot of Dungeons and Dragons. I don't know if anybody else here does, but just in case you do, I really think it looks a lot like a D8. So that's what I saw. Okay, and the last item, the Kepler space mission. So NASA has officially ended it. Not because they wanted to, not because of a big disaster or anything, but because it just ran out of fuel. So it has reached the end of its fuel and its end of life. But it is, I think Kepler is one of those missions that I think will go down in history as one of the greats. And there's certainly a few out there, but I mean this was a mission to go and find other planets of Earth size and Earth orbital periods, Earth-like orbital periods around other stars. So I'll talk a little bit. So if you don't, I think most people in here know what the Kepler space mission was. But what it was trying to do, like I said, was trying to find these exoplanets. But what was novel about it was they basically said, so ignore all these, just pretend these aren't here. Okay. This was where it was predominantly looking for the first chunk of its mission. So they had enough. I forget exactly what it was, but for like the first 3.5, 4 years, they had enough something that allowed them to stay pinned on this area of the sky, okay, for extended duration. And what the way you do it is, so what they did was they said, you know what, we're going to look at this patch of sky, and we're going to look at it for over 3 years, right? And so what that does is it allows you to see the planet. So what you're actually looking for are dips in the light of the star as the planet passes in front of the star, right? So star comes in front of the planet comes in front of the star, right? Light goes down, right? The Kepler spacecraft is able to detect it, right? Now, it's looking at tons and tons and tons of stars, right? All at the same time. It's also doing it for 4 years. So what that means is, you get your first blip, right? Okay, well, let's wait about a year, or however long it is, and say you get another blip in about an Earth year. That means it's got the same orbital period as Earth, right? And then you wait another year, and you get a nice confirmation. You get a nice confirmation of how long that year actually is. So you get a little bit of extra data in there. So they did this for a while. They went into a second stage of the mission just to try and get more life out of it. And they were looking at different parts of the sky for much less time. So the stats are pretty remarkable. So 530,000 stars observed, confirmed over 2,500 planets. While that was going on, they were also documenting supernova because you're looking at the sky constantly, so you see these things. They used 3.12 gallons of fuel. Not that much. But they pulled down 670 gigabytes of data, which is decent. 3,000 papers published. I'll talk a little more about that. And it's trailing behind us by about 94 million miles, where it will continue to hang out for the foreseeable future. The number of exoplanet discoveries. I mean, I don't know if you can tell where the where the big jump is on this bar graph, but I think in the future, I imagine, like, I could totally imagine, like, I don't know, 100 years from now or whatever, maybe a couple hundred years, who knows what it'll be, but somebody's going to be up here giving a presentation like this, because that's totally what it's going to happen. This is the thing I'm imagining in my mind, and they're going to look back, and there's going to be this little blip in, like, 2014 when we discovered, several thousand of these things, and then, but the actual number of exoplanets known will be, probably like in the tens or hundreds of thousands by that point, right? And yeah, it was, not only was it a massive success in terms of exoplanet discoveries and, informing us of what's out there. Amazing when you think about it. Sorry for the white. There have been an incredible number of papers published. Like I was saying, there was something like close to 3,000 papers that used Kepler data. And it wasn't all just exoplanet stuff, right? So there were things where people found use of the data for microlensing, astroseismology, galactic archaeology, whatever the hell that is. Classical pulsators, white dwarfs, open clusters, books and binaries, young stars, solar flares activity, solar system science, it was it's a remarkable spacecraft and one that provided an incredible amount of knowledge to humanity. So I just wanted to give a little bit of a nod to the mission. And so speaking of giving nods, I just wanted to throw us up that it's Carl's birthday. So happy birthday, Carl. You would have been 84 today. So on that note, we will break for refreshment. If you would like to be entered into our draw for this book, you may see Chris at the front. He will give you a ticket. Keep onto that ticket, and we will find a winner after the break. We'll mix them back in. We'll mix them back in.
Anybody else?
Okay. We got it.
398 3944.
Okay.
That's it? Yeah, it's all right. You're being impeded. That's fine. I will note it is. It's also signed.
That is so cool. Thanks, Gail.
Yeah, it's signed by Gail.
I do want Gail's signature.
So, thanks again to Gail, and thanks to Chris for putting all that together. Is there a Benedict here tonight? Looking for a Benedict. Okay, so Benedict, and you didn't say so, you have a calendar here. Okay. So for a future presentation tonight, we have one of our members, Alan, who will be presenting on astronomy travel. So as I was saying earlier, sometimes if you're heading around, there are a lot of really cool astronomy sites and various things out there that probably don't get advertised all that much. So Alan and I were talking back in Spruce Woods about some, just some ideas about some astronomy travel, and it might make a cool presentation, and he offered to give us one. So please join me in welcoming Alan.
This is a personal view, meaning that if somebody else did this, they could have a totally different presentation with totally different views, etc. So whatever you see is what I happen to like. You may or may not like it, but this is what I like. Now, most of these photos are my own, although the places I haven't been, I didn't take pictures of them, but the few that are here. Now, traveling is fun, but that kind of stuff is fun too, but you have to have some kind of goal. I think it makes the travel a lot better. So why not use astronomy? If you look at the date on the picture there, it's August 21st, 2017, so you know where that was, somewhere along the center line. There's several reasons you can travel. One is to specific events, but you can visit places or people that you happen to like. But the nice thing is that along the way you get surprised. You see things that you weren't expecting to see, like this almost live T-Rex at Casper College, Wyoming. And eclipses. This is an almost eclipse. And if you're smart, you can get paid to do it. And some people do. Alan Dyer, he's got a job with Norwegian Cruise Lines now. I think somebody here does some work for other travel people. Ron, member of the Saskatoon RASC, in the white t-shirt there, he also got a job with Norwegian Cruise Lines, and they go up near the Arctic Circle, and he talks to everybody on the ship about northern lights and whatever else is in the sky, and he gets paid for it, which I think is kind of neat. This guy from Harbin, China, he spoke English very poorly, and he was broadcasting all this. This is at the August 21st eclipse. And he had a pile of equipment. I don't know where he got it all from, but it was all kind of neat stuff. And he had a Toyota Sequoia running with motor running all the time to power all this equipment. So he was doing quite a fancy job. Fred Espinac was there too, and I bought one of his books. He's selling books and t-shirts, and if you bought 2 books, you got a free t-shirt. They call him Mr. Eclipse. He's done quite a bit of work on Eclipse websites. And the rest of us paid our dues. This is Astrocon 17 in Casper, Wyoming. And the circle in the center of it, you can see a balding middle-aged fellow. That's me. There he is. There's quite a few balding middle-aged fellows there, but there was quite a bunch of that group. The first eclipse I went to was in Albuquerque, an annular eclipse. And I hadn't gone to any eclipses before, and the thought of going there never occurred to me. And I thought, gee, I should do this. How long am I going to wait before I do it? So I looked around on the web and found a good map, and found the center line of the eclipse, see what it went through. And I thought, in New Mexico, there's not many clouds there. Maybe I should go there. And I looked on this guy's website and found a bunch of good information about cloudiness and weather patterns and so on and so forth. And I ended up going to an event at Petroglyph National Monument, which is just to the west of Albuquerque, New Mexico, which is a really neat place. And they had an event hall set up there. But the thing about going to it is when you drive there, you meet stuff along the way. Of course, we stopped at the Carlsbad Caverns, and of course we saw all that neat stuff you see in caverns. And I stopped at the strangest, Penny and I stopped at the strangest cemetery I've ever seen. This is a fellow's gravestone, going for Gas Larry. It's in Madrid, New Mexico, along the Turquoise Trail. Of course, we stopped in Roswell, and there's other visitors there too. It's a great place. It's kind of odd because they talk about flying saucers, and it's very cleverly worded. They don't say there aren't flying saucers, and they don't say there are flying saucers, but they talk about this so much that after a while you have to start thinking, well, gee, are there flying saucers? And it's quite skillfully done. I don't know if it's true or not, but it's skillfully done. And of course, they have a gift shop. This is one of the best stops we made at Socorro. And that is a really neat place. It is just, I'm sure everyone's seen it in movies, but it's quite exciting just to be there. The vastness of it all, it's at 7,000 feet. It's on a huge flat plain surrounded by mountains, and it's I think they've chosen the site perfectly. I imagine the skies there are amazingly dark at night too. It'd be probably quite nice. And they can move these things around in a denser or a looser configuration depending on what's going on. And they sell great T-shirts. The software has been upgraded quite a bit to give more information, and we got quite a fascinating talk on that when we were there. Finally, we arrived at the Petroglyph Park, and it was really well organized. Here's the bus that's going to take us out to the park. We park our cars, and we all get on the bus. And there was security and police there. It was all well organized, and this is Ranger Luke. Ranger Luke was the guy I was corresponding with by emails to get the tickets for it, and so on and so forth. And I just love the U.S. Ranger hats. They're really neat. And he was trying to sell it as an astronomy site, but you know, you can plunk your telescope down almost anywhere in New Mexico, and maybe not to San Albuquerque, but most other places, and it's just great. You know, there's a lot of it there's not many people there. I got set up next to this fellow. It was just fascinating. He had really good eyes. He could, just as it was getting dark, he could spot Saturn very quickly. It was quite impressive. How sharp his eyes were. And you meet people, and you have these great discussions. I don't know if they ever get settled, but we have them. I got interviewed by NPR. Penny took some of these pictures, and I was trying to look important there. I don't know if I was or not, but of course she had to look through the scope, give a play-by-play of the eclipse, and the Rangers have had a look too. So there's about 20, 30 people at this event, and there's off to the left, you see another bunch of people there. E.C. Krupp, who was the director of, where's that word now? Observatory, I'll show you later, in Los Angeles, was running another event there at the same time. And the Washington Post ran this picture in the newspaper. Because Penny and I happen to be the farthest travelers at the eclipse. Now they wonder, why would somebody travel all that way to see the eclipse? They thought it was somewhat amazing, but it's not. Finally, the eclipse does happen. It was neat to see, just to watch the ring develop. And there was still, the eclipse hadn't finished at sunset upon they took the filter off. sensors on the camera, but everything was fine. Well, where do you go to next? Well, how about Chile? Let's go there. Bob Berman, with his daughter, to your left, she's in the travel business, and he helped arrange this tour, and it was through Astronomy magazine. And I thought, this is great, I want to go there. I said to Penny, you want to come? Nah, I don't want to come. And she thought it would be a bunch of middle-aged guys in a shack in the dusty desert with tumbleweeds blowing by. And it was anything but that. It was really a well-done tour. We saw a lot of neat things and went to a lot of neat places. And it was a very memorable place. We started off in Santiago for a couple of days, and then we flew to La Serena, and then finally up to Vicuña, and we drove elsewhere afterwards, but there was an observatory just to the east of Vicuña that was very, very nice. But Santiago was kind of touristy. The restaurant we went to was kind of neat, and then they happened to have a very famous visitor there previously, so they had that picture prominently displayed there, so we were quite proud of the restaurant. But it is a bit touristy, and that's a little overdone. Astronomy country. My Spanish isn't that good, so I won't try to pronounce it too much. But the roads up there to the telescopes and the radio station. A rough ride. The roads weren't very good at all, but finally we reach and can get up there, and it was quite a beautiful place. And they had a pile of scopes up there too, a 20-inch, which is always fun to look through. And a bunch of smaller ones too, and it was fairly warm. It was a beautiful night. But I found it a little confusing. That's one of the Magellanic Clouds there. But the constellations are all in the wrong place. And it's kind of disorienting figuring out where everything is. And, I think our first speaker tonight maybe gave some useful hints that I should have been using to find just the basic positions of the stars before I get confused, because I kept leaning backwards to find Orion. I took this with a 50mm lens, and I had it open too much, and I should have stopped it down a bit, because the edges of it are a little distorted. But I'd never seen Magellanic Clouds before, and they're quite easy to see. And that was one of my favorite things that I saw there. Bob Berman gave us a talk just at sunset, or just after the sunset, and right behind him, right across the sky, there was this bowl light, huge bright meteor, and then it exploded in the air, as if he arranged it for his own benefit. It was almost too much. I'd never seen a bowl light before either, and that was kind of a nice free bonus to the trip. This picture I took, Venus in Sagittarius with zodiacal light. Bob Berman's daughter liked it quite a bit, so she used it in her ads that got into Astronomy magazine for a couple of years. They've dropped it since, but they didn't pay me. We traveled a bit, and we could see other observatories in the distance. I think that might be La Silla.
astronomers do. I don't know if that's exciting or not, but that's what they seem to be doing there. They have a series of smaller scopes. Some of them are just to see what the seeing is like, which is usually excellent. And the skies are just beautiful up there. I think it's about 7,000 or 8,000 feet that I was up. And then they have a mirror in good position for us. And I've never seen such perfect glass in my life. It was just looking at it. I don't know, I got real excited about just seeing all that nice glass. 6.5 meter scope. And when the thing moves, it's silent. It's as if it takes no effort whatsoever. It's just watching all that perfectly organized, well machined stuff move around without any effort was it just, ooh, I just loved it. That's one of the mirrors that after the secondary mirror sends it off to various instruments. And that's the secondary mirror up there. And that's some of the instrumentation. I have no clue how that all works, but it looks fascinating. They do a lot of spectroscopy there, and there's a plate about this big, and they focus the image on it, and they do a template of the stars they want to look at, and they have a feed on it that goes, I guess, into their information storage, and this fellow was explaining the details of it. I didn't quite understand it really well, but it was kind of a fascinating thing to see. And then they took a good picture of us under perfect skies. Well, where to next? This is Jantar in Rajasthan. It's the world's largest astrology observatory. I know that's a bad word. But it was absolutely fascinating. You can see people in the background. This thing is absolutely huge. It's enormous. They have, you can see where the sun crosses here, and this is all marble, very nice marble, and it's all graded very finely so that they can measure the exact positions of the sun at the time, and you can measure the different planets at night, etc. And the exact time of your birth and the exact positions of different planets apparently decides your course in life. I know that's been unproven, or disproved, but there's a lot of people that believe that. Although some of the stuff they showed looked kind of familiar. These are your basic planets of antiquity. And this is another type of observatory, and marked out with a great deal of effort, time, money. I don't imagine a huge amount of effort went into building this a couple hundred years ago. And it's just really fallen out of use, but it's a great tourist attraction. Well, let's go someplace closer, like Mauna Kea. If you get a chance, go there. It's absolutely wonderful. 13,500 feet. You can drive your vehicle up there, but if you're renting, I was told that the vehicle insurance above 9,000 feet, which is the visitor center, is invalid, so that if you get into an accident, you're out of luck. But people seem to drive up on their own, and there's traffic jams in the clouds. Penny and I did take a tour, and that was a little easier way to go, because you just get on the bus, you get off the bus. But it's, excuse me, it's absolutely fascinating though, because you're just above the clouds, and it's quite cold. I brought long johns when we went to Hawaii. Not many people do, but I did. Beautiful place. Zodiacal light was so easy to see. I've never never seen it in Manitoba, but I've seen it there quite a few times. And I didn't actually see this, but when I looked at the pictures later, the adaptive optics laser from one of the Kecs was shining that night, and that made for kind of a neat picture. I quite like that. They have a really good visitor center there, and they give talks on various things. And there's a hill nearby that I climbed up every night, that I could when I was there, and it's very popular. The sunset there is just beautiful. A lot of people go there. I heard a lot of German, a lot of Chinese. A lot of Japanese there. Everybody gets into the act.
Alan, where were you staying while you were going up and down?
Oh, we're at a hotel where there was a medical conference, which is how I ended up being there. But most people rent a car when they're there, and you just drive up. It's not that big an island, and it's maybe half an hour drive, depending on where you're from. You don't need to stay nearby. You can just drive up from almost anywhere. That's Mauna Loa in the distance. And people come for this, the sunset. You can see there's shadow in the background there in this picture. And it's above most of the clouds. The air is a bit thin, but people like it. They're all dressed up. And the skies there are different too. That little bump on the hill in the center just above it is Polaris. So it's quite a different spot, and there's some more zodiac light. It's so easy to see there. I think Stephen O'Meara talks about people trying to see split double stars, and they'll go up on top at 13,000 feet, but they'll take supplemental oxygen. I'm told that your retina doesn't work very well at 13,000 feet, and some people say you can see better at 9,000 feet just because your retina isn't hypoxic. I'd like to try that out sometime and see which is better. They set up equipment after sunset with viewing. They've got about 10 or 15 scopes there, and it's quite busy. So I started helping out and setting up the dogs and calibrating and whatnot. And after 3 nights, they offered me a job as an unpaid volunteer. And Penny, I want a job. I'll quit my day job. I didn't quit my day job, but I was tempted, and I did want to go back there. It was a lot of fun. This is Casper, Wyoming, and I think most of us have our eclipse stories to tell. I think most of us did one thing or another for it. This was at Astrocon 17, which is their annual, the Astronomical League of United States. I guess it's the closest thing they have to the RASC, but it doesn't seem to be as all-encompassing as the RASC does, and they don't have the RASC handbook. So it has parts of it, but it seems to be a fairly large national organization. What they do have on their website, which really surprised me, was the number of astronomy projects too. Like the Colander list and the Messier list and all the rest of them. But they have, I don't know, it seems like 100 of them. So if you ever go on their website and you're looking for a project, they do have a whole bunch of them, quite a few. And they had us viewing at Casper College, which was where that T-Rex is. We booked our hotel about 2 years in advance for about a hotel room for about $100 a night. By eclipse time, it was more like $300 a night. There were people selling lots of dirt on their farm for $100 a night for the eclipse, or $100 for the day for the eclipse. And so if you find a place to go, book it early. Casper is stargazing up at 8,000 feet. It was quite good. It was quite nice. It's, I think, about 35 degrees latitude, so finally I could see all of Sagittarius. You know how you look, or Scorpius, sorry, you look at Scorpius and you can't see the bottom of it, you see what's down there, and the bottom of Sagittarius gets kind of caught in the atmospheric turbulence, so it was higher up here, and I got to see quite a bit more of it, and I quite like that. Now, the town of Casper really didn't think the eclipse was a good idea, and it took them quite a while to get into the whole thing. But once they did, they went whole hog, and they thought it was a great thing because they made a huge amount of money with it. And the media got in there. And this was Eclipse Day, and there they were. This is the mayor of Casper declaring that the weather will be perfect. And it was. The Astronomical League actually had a really good bunch of speakers, a number of NASA people. There was a good talk on the Osiris Rex and a few other NASA projects, a lot of dark sky stuff. This was a dark sky talk, and Saskatchewan seemed to feature prominently on that. And of course they had displays there, and they had lots of dealers there, and I don't know if anyone here needs a new telescope, but they had lots there for sale. So watching the eclipse, a lot of people had a lot of good equipment there. It was fascinating walking around, just oohing at all the neat stuff that they had. And we all showed up, I think the eclipse was closer to noon, but we all showed up quite early to set up, and the eclipse started right on schedule. And this is where it got exciting. Must have been a couple hundred of us there, and somebody shouted, "Filters off!" And the goosebumps started, and then the goosebumps got thicker. I let a video camera run, filming me while it was going on, and I was rubbing my arms during the thing because I was just covered with goosebumps. And when you read about eclipses, you hear about the goosebump effect, and it's true. Just your arms get full of goosebumps. It was quite an event. And I had all my cameras running and snapping pictures like crazy, and it was a really good day for an eclipse. This is with the filter on, and then during the totality, there was just a little bit of cloud there. I took the filter off and took one or two pictures, and then put the filter back on and have cables and stack them all. Well, where else can you go? Well, you may not be able to travel far, so you go to some place that's closer. That's the transit of Venus, and that's Venus being occulted by the moon a few years ago. And I said, Penny, we've got to go see the transit of Venus. Oh, where do we have to go this time? Front yard. And this is my front yard, and that's one of my partners looking at the transit. So, well, where else can you go? Well, this is a book that I bought a few years ago, a guidebook for scientific traveling, and I quite like it. It's American though, so it just lists U.S. places, which is quite a bit. You know, there's an incredible amount of places there to see. It's not big on Canadian stuff. It deals with quite a few different unique places. And I would like to go to some. I've been to a few. Now, Canadian places. This is RASC map of dark sky sites in Canada, of which apparently there's none in Manitoba.
Working on it.
I don't know if that's not true. There must be some dark place in Canada. Now, according to Global News and the Canadian Space Agency, these are the 13 best places for astronomy in Canada. Whiteshell Provincial Park, Grasslands, Jasper. A lot of the other places I'm not familiar with. but those are the ones I am familiar with. They left out this place, Sprucewood Star Party, and they left out the Cypress Hills Sky Preserve, which I usually try to get to every year. That's Les Dickinson who organizes it every year. He does quite a good job of it, getting everything going there. But Penny and I did spend one evening in Grasslands National Park in southern Saskatchewan, and it is really dark there. There's just nothing there. We stayed in a town called Val Marie, and there's an old nunnery that's been converted into a hotel, and it's it was quite a neat place to stay. The rooms are, the ceiling's about 12 feet high, and it's 100 years old. It's quite a neat place. I didn't do any Canadian observatories like the David Dunlap and so on. But where does this fellow suggest? Well, there's Native American sites, and there's a surprising number of them. There's one place called, the one in Illinois they call Woodhenge, in that it marks various times of the year astronomically, but with wood and not with stone. And there's other places that they visit as well. Mesa Verde, Mesa Verde, I've heard about it. Optical scopes, these are the ones I'd certainly like to see. The U.S. Naval Observatory in Washington, it's not quite as good as the others, but and it's not as accessible as the Smithsonian's are. San Jose has Lick Observatory, and it might be kind of a neat place to go. They've got a hardwood floor that goes up and down for ease of viewing, and it's made some important discoveries in the past. It's got a refractor, a very large refractor, and of course Lowell Observatory in Flagstaff. The Pluto Discovery Scope, I wouldn't mind seeing that as well. And there's also a Discovery Channel telescope at Happy Jack, Arizona. I'm not sure exactly where that is, but it's somewhere close to Flagstaff. Now, Yerkes I wouldn't mind going. And Carl Sagan spent a year there. I guess he was, I don't know if you'd call it an intern or a resident, but or at least that's my terminology, but a lot of important people spent some time there, and Einstein was quite thrilled to visit there back in his day. Now, the Hooker reflector, Mount Wilson in Pasadena, that's where Edwin Hubble found a variable in Andromeda, and that was an important, really important event in astronomy. The Hobby Everly scope, I've always been fascinated that it was such a big scope in Texas, and it's not really that high. It's about, I think it's about 5,000 feet or 500 feet, but it's a huge scope, and it only rotates, but it nearly doesn't tilt. They've got a mirror at the top, which tries to get most of the sky that way. Apparently, that saves a great deal of money. But the fascinating part about it was the 82-inch auto-struve reflector had a chunk shot out by a deranged visitor, which that's for Texas. I guess you can do that in Texas. Shouldn't do that here. So there's quite a bit to see there. The Palomar Observatory too. It's of course everybody knows about that one. It was the largest telescope in the world for a long time, quite a long time. And it's got some features of it which I found quite neat. Because the whole truss thing bends with its own weight, they factor that into the construction so that it doesn't affect the focus or alignment, and Peak in Tucson is, outside of Tucson. I've read about their outreach programs, and they're apparently quite good. They have observing night, and they have evenings, and they have overnight observing. They air condition their scope, and the dome is on a separate foundation to reduce all the vibration. So it's, these are well-built things. What about radio telescopes? This one here at Greenback, I wouldn't mind seeing that. It just looks so neat. I wouldn't mind seeing that. Now, this Arecibo, from what I've read, it is falling on hard times. They've used it in movies and whatnot, I think the James Bond movie. But it apparently isn't being maintained as well as it has been, and it's falling on hard times. And this is the up-and-coming one in Guizhou, I don't know if that's pronounced correct, but Guizhou province, China, is slightly bigger than Arecibo and is starting to work now. It's got a slightly different design as well. Planetariums. American Museum of Natural History in New York City is one place I do want to go. They have the Hayden Planetarium, and it's supposed to be the best projector in the world. They've got, it's a big, big place, and a lot of stuff there. It can keep you occupied for a long time, such as the Willamette meteorite. And that would be kind of neat just to walk around and gaze at it. And a galactic armillary sphere. Now, the Griffith Observatory, one of my partners has gone down there a couple of times, and we just love it. It's, of course, more Hollywood than anything else, and you've probably seen it in one movie or another. There's Wikipedia has a list of all the movies that feature the Griffith Observatory. But it has the most observed telescope in the world. More than 7 million people have looked through this scope since it was installed in 1935. So that's the world's most used telescope. It's got all kinds of stuff there. Different halls, different exhibits, all kinds of neat things to look at. And that's Ray Bradbury giving a talk at the Leonard Nimoy Event Horizon Theater. Leonard Nimoy apparently contributed quite a bit of money to the construction of it. Now what about exploring different places? Ames Research Center in Silicon Valley, Goddard Space Flight Center in Greenbelt, Maryland, JPL in Pasadena, Kennedy Space Center, and the Stennis Space Center in Gulf Coast. That's where they do engine testing, if you can find what they're doing the fire. This is the world's largest wind tunnel at Ames Research Center. Goddard Space Flight Center, and you know what that is, of course. It's the James Webb Space Telescope, and it's still on the ground. I found this ad for JPL from the 1960s fascinating. It's a very attractive ad to go work for JPL. But they also hired females very early on in their in the course of events. First female engineer. But of all the places, I think this is the one I want to go to probably most. The Rocket Garden I certainly want to see. I think that's an Atlas 5. Yeah, probably an Atlas 5. And that's definitely what I want to see. The website is very good, and they have launch schedules there if you want to see a launch, etc., etc. Now, museums, I've been to a couple of these, and the National Air and Space Museum in Washington Wall. And that was a pile of stuff there. And it is overwhelming at times. The Apollo 11 capsule, which is, they've got it all protected in Space Center, that's the guy who paid a lot of money. It's right near Dulles International Airport. But oddly enough, to get to it from downtown Washington, D.C. takes about 3 hours through various buses and whatnot. It's the beautiful subway system, for some reason, doesn't go out to Dulles. But what surprised me is how big the space shuttle is. I didn't realize. I thought it was like a minivan or something, but it's absolutely huge. And just walking around it, you see people in forward. It was just fascinating to see. Wow, it was quite impressive. Johnson Space Center, Houston, we have a problem. They have a large visiting area as well, 250,000 square feet visiting area. And of course, there's a manned spaceflight center there that we've all seen. And astronaut training facilities, of course. And in New Mexico, there's a Museum of Space History in Alamogordo, which is right near the Trinity site where the first atomic bomb was used, and near White Sands Missile Range as well. And they have a 5-story museum there. And it has kind of odd things. Robert Goddard did a lot of his early work around that area, so they have his stuff. And some fellow by the name of Dr. John Strapp, who set a world speed record of 632 miles per hour in a rocket sled in 1954, and survived. And they have other odd things there like that. Where should you go? Well, depends what you want to do. A dark sky map can certainly help. Eclipse maps are available, and my friend Graham was asking me about lunar eclipses, and the RASC handbook has everything for the year, but you can go online and get it for years in advance. This book I bought from Fred Espenak. I got it for the 2024 eclipse, but he's got books for roadmap books for a lot of other eclipses too, which you can use as a guide for going to different ones as you see fit. So I'll conclude by saying I've shown you some places I've been to, shown places I want to go to, but where you should go depends on your personality and your budget. Thank you.
Questions or any commentaries, travel suggestions, even your own experiences?
Yeah. Are we ever going anywhere that doesn't involve science or astronomy? I get left behind at the hotel while you drive out on the key every night.
That sounds like a great opportunity to go and enjoy yourself.
Go on
No.
to cruise.
Yeah. No, thanks, Alan. Yeah, one of the things too I wanted to mention, as Alan was talking about his experience on Mauna Kea and sharing a lot of his knowledge with people around there. I've certainly had that experience too before. I was camping in New Zealand, and so we were at this campsite, and I was out one night with my binoculars, and somebody came by and was kind of curious, like, what are you doing? You know, kind of thing, right? And like not accusing or anything like that, but just kind of curious. And I said, oh, like I'm from Canada, I'm just here to see the skies down here, right? So, and I start talking like I know what I'm talking about, because that's what I do. But of course, I have no idea what I'm looking at, right? Like I've barely learned the southern skies at all. So I'm just like, so I go from like talking like I know what I'm talking about to fumbling through trying to explain to this poor person like this is what you're looking at. But it was actually a really positive experience because I basically just handed them, like we shared the binoculars back and forth, and I was showing them around, and they really got a kick out of it. They really enjoyed it. So, you know, when you're traveling and doing this stuff, I mean, it's actually a really good opportunity for you to share your knowledge, because you're going to run across a lot of people that actually have no idea that this is something that they can do. Right? So, yeah. Anyway, so what's up?
Hi, I have some comment to make.
Yeah.
It's worth noting that Manitoba actually placed number 8 out of the top 10 Lonely Planet regions in the world to visit.
That's true.
And the line to Churchill has been reopened.
Yes. So if you want to go, Aurora hunting, or and go see some polar bears too, maybe. Get your butt up to Churchill, because there's some really good aurora doing up that way. So as our meetings usually go, we will be continuing on at Boston Pizza over various beverages, some red, some otherwise. So it's the one down on Pembina. If you want to join us, feel free. Otherwise, have a good night.